Hello, everyone, and welcome to another edition of Astro Trivia from the Dunlap Institute at the University of Toronto. Thank you all for joining. Just as we get started here, we're gonna get you all to join the game. So if you go to kahoot.it and you put your name into, you put the game pin into kahoot.it. That's 4467142. So the big number you see at the top of the screen there. Just put that into kahoot.it and that will register you for the game. Now keep in mind as you're putting your name in that you should put your actual real email address, because otherwise we will not be able to contact you if you win a prize. However, we will promise not to contact you unless you do win a prize. So your email information is safe with us. So we'll just wait for a few people to sign in here. And then we'll get started in just a few minutes. While we're waiting, feel free to interact in the chat, say hi to your fellow game players, say where you're from, say a cool thing about yourself. Keep it kind and fun. But yeah, feel free to introduce yourselves in the chat while we're waiting to get started here. Apparently, we have someone from the TRAPPIST system coming from a far, far away. Mississauga, hello. Hello from Toronto. Hello from Mimico. So for those of you just joining, welcome to Astro Trivia. Please go to kahoot.it and put the game pin in kahoot.it in order to be able to play the game. Or if you're fancy, you can use the QR code that appears at the top of the screen, or you can download the Kahoot app, whatever you're feeling like. Just go to kahoot.it and put in the game pin. And hello from Toronto, hello from Newmarket. It's great to see you all here. So we're just going to give it a couple more minutes for more people to join, and then we'll get started. Hello from Ottawa. More Torontonians, great to see you here. Of course, I'm at the University of Toronto right now, so you're very close to me, which is wonderful. Give it another minute or two. So those of you just joining, once again, third time's a charm. Please put your game pin into kahoot.it. And we've just put it in the chat as well, so if you want to copy and paste, go ahead. All right. So a reminder that when you sign into kahoot.it to use your real email address if you want to have a chance of receiving a wonderful prize. If you do win, we will contact you by email, but if you don't win, we won't. So don't worry, we won't use your email for anything other than just contacting you if you win a prize. All right, so let's get started. It's great to see you all today. Before we get started with our games, I'd like to do a land acknowledgement since we are in Toronto, and even though we're operating online, I'm currently working on the University of Toronto grounds. So we wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. So welcome, and let's get started. So welcome to Astro Trivia. Our theme today will be exoplanets. So we're just about to get started. And before we officially get started, I'd like to plug some of the other content on our YouTube channel. So presumably you are watching us from the Dunlap Institute YouTube channel right now. And if you want to check out some of our other content, we do have a bi-weekly series, which we call Cosmos from Your Couch. And here are a few of them that just recently came out. And we're planning on having our next episode come out tomorrow, in fact. So stay tuned for that. Go back and watch some of our previous videos. They're only about 5 to 6 minutes, so not a huge time commitment, but we are really proud of them here at the Dunlap Institute, and we hope you enjoy them too. So let's get started with the rules for the games. So anyone can play, but unfortunately we can only send prizes to Canadian addresses outside of Quebec. It's just because of rules, but if you do have a Canadian address outside of Quebec, we can send you a prize if you happen to be one of the top 3. People with graduate degrees in astronomy or some equivalent expertise are not eligible to win prizes. This is just to make it fair for everyone who maybe doesn't have a PhD in astronomy. If you're under 18, make sure that you do have your parents' permission to play. And with that in mind, since there may be people under 18 in the chat, please keep it respectful and family friendly. And as I already said, if you want to have a prize, you have to use your real email address in Kahoot. If you didn't put in your real email address and you want to go back, just go back to kahoot.it and re-put in the game pin and start all over. And we promise that we won't use it for any reason except for to contact the winners. All right, and now for the fun part, the prizes. So, our prizes this evening are some pretty exciting ones. Our first prize is this Celestron travel scope, which has this cool smartphone adapter that you can put on the end of it so you can take pictures through your telescope. It's very nice and, a very exciting prize. And we haven't given away a telescope in a little while, so we figured it was about time. For our second prize, we have the return of the ever-popular moon globe. It's always everyone's favorite, is one of these lamps that you can hold in your hand, and it looks like the moon, and it's very pretty, and it changes color. Then we also have, as our third prize, a color-changing mug with constellations on it. So as soon as you put your hot tea or hot coffee inside the mug, the constellations appear on top of the stars, and you can maybe learn something about the constellations. All right, with all that said, let's get into the games. So our first question of the evening is, which telescope has found the most exoplanets to date? Exoplanets being extrasolar planets, that is, planets around other stars. Is it the Hubble Space Telescope, the James Webb Space Telescope, the Kepler Space Telescope, or the Transiting Exoplanet Survey Satellite? Which one of these has found the most exoplanets to date? So get those answers in. You've got about 3 seconds left. And it looks like most of you got the correct answer. Excellent job. It is in fact the Kepler Space Telescope, which on its own has discovered well over half of all of the extrasolar planets that we have found. So if you want to see it again, that is a sort of in shadow view of the Kepler Space Telescope, which has discovered thousands of planets on its own. Let's take a look at the leaderboard to see how you all did after that first question. So we have Fearless Seal in first place, Dazzled Unicorn in second place, Radiant Squid in third place, and Proud Ostrich and Space Bunny coming up in fourth and fifth. So remember that the faster you answer the questions, the more points you get. And the more points you get, the higher you are on the scoreboard and the closer you are to winning wonderful prizes. So with that in mind, let's go on to the next question, which is, what method has been used to detect the most exoplanets? Is it the transit method, the radial velocity method, direct imaging, or gravitational microlensing? Which method has been used to detect the most exoplanets? The transit method, the radial velocity method, direct imaging, or gravitational microlensing? And once again, most of you have gotten the correct answer, which is the transit method. So that is the method which the Kepler Space Telescope has used to detect most of the planets that it has detected going around other stars. And basically that is just looking at the star's light and watching for little dips in brightness as the planet transits in front of that star. And if you see a regular dip, of a planet going in front of that star in the dip in the light, then you can assume that there is a planet there. And to describe a little bit the other methods, the radial velocity method has to do with the gravitational tug of the planet causing the light of the star to shift ever so slightly, which was the method that was most used prior to the Kepler Space Telescope. There's direct imaging, which is sort of explanatory, where you just take a picture of the planet directly, and gravitational microlensing, where you look at the very slight shifts in light caused by the gravitation from the planet itself. Let's look at our leaderboard once again to see how it has changed. And Dazzled Unicorn has moved into the lead, Radiant Squid in second, and Aquatic Impala, which is a very interesting type of animal, has moved into third. All right, let's move on to our next question. This is a true or false question. The closest star to us, Proxima Centauri, contains a planetary system. Is this true or false? So does Proxima Centauri, the closest star to us, contain a planetary system? Is this true or false? You've got about 12 seconds left. So again, remember that the faster you get those answers in, the more points you get. And most of you got the correct answer, which is that yes, there is in fact a planet going around the closest star to us. The closest star is, still very, very far away. It's about 4 light years away, which is about 40 trillion kilometers away, which would take us tens of thousands of years, even with our fastest spacecraft, to get to now. But it does indeed have a planetary system, and this, I just saw in the chat, isn't the star closest to us the sun? And yes, it is. I meant the closest star besides the sun. Sorry, should have clarified that. But yes, the closest star to us, Proxima Centauri, does indeed have a planet going around it. And we think that that planet may in fact be in the habitable zone of that star, which is kind of exciting. Looking once again at our leaderboard, we have Dazzled Unicorn maintaining the lead, Radiant Squid in second, and Space Bunny has moved up to third. On to our next question. About what proportion of currently known exoplanets are terrestrial, rocky, and about Earth-sized or smaller? So what proportion of currently known exoplanets are Earth-sized or smaller? Is it over half? Is it about 1/3? Is it about 10%? Or is it less than 4%? So you've got 10 seconds left. Get those answers in. Is it over half, about 1/3, about 10%, or less than 4% that are rocky or smaller than the Earth? It is in fact less than 4%. So that's just the exoplanets that are rocky and Earth-sized or smaller that have been detected. But as you can imagine, a small planet like that would be very difficult to detect. So we assume that that's why we haven't seen a whole lot of them. But of the planets we've detected so far, only less than 4% of them have been these rocky planets that are Earth-sized or smaller. Looking once again at our scoreboard, it has changed completely with Awesome Gazelle in the lead, Lively Possum in second, and Glowing Sloth in third. So let's keep going and see how things change in the future. What is the most common type of exoplanet that has been detected so far? Is it gas giants, Neptune-like planets, super-Earths, or terrestrial planets? So what is the most common type of exoplanet that has been detected so far? Is it gas giants, Neptune-like planets, super-Earths, or terrestrial planets? Got about 5 seconds left to get those answers in. And I got you with that one. Again, the most common type of exoplanet that's been detected is actually Neptune-like planets. So we've detected a lot of gas giants, but most of the planets, or the greatest number of planets that we've detected, are actually smaller gas giant planets, or smaller than gas giant planets, and are more like Neptune. So smaller in size, less massive. So yeah, but there are a lot of gas giants that we have detected. Looking once again at our scoreboard, it hasn't changed that much, except for now Witty Panda is in third. Excellent job. Our next question is, what type of planet was the first to be detected around a sun-like star? Was it a rocky planet? Was it a super Earth? Was it a hot Jupiter? Or was it a Neptune-like planet? So what was the first type of planet to be detected around a sun-like star? A terrestrial planet, a super Earth, a hot Jupiter, or a Neptune-like planet? And most of you got the correct answer. Excellent job, everyone. A hot Jupiter. That is a planet that is a large gas giant, just like Jupiter in our own solar system, but is very close to its star and is therefore hot. And this is an artist's depiction of what a hot Jupiter would look like. A gassy giant that is very close to its star and therefore very hot. And we think that maybe these types of planets might get evaporated away by the star quickly, but of course we'd have to observe them for a long time to see that happening. Looking once again at our scoreboard, we've got Lively Possum in the lead, Glowing Sloth in second, and Witty Panda down in third. Our next question is, how many planets have been detected via direct imaging? That is, how many planets have we directly taken a picture of? Is it 12? Is it 245? Is it 97? Or is it 61? So how many planets have we directly taken pictures of? 12, 245, 97, or 61? All right, time is up. And a pretty even spread. I suppose if you just randomly chose it, that's about what you'd expect. And the answer is in fact 61. So we think that thousands of planets, or we have detected thousands of planets via the transit method, a couple thousand via the radial velocity method, but only 61 planets have we directly taken a picture of. Looking once again at our scoreboard, we've got Glowing Sloth in first, Radiant Squid in second, and Space Bunny in third. All right, another true or false question. There are more stars than planets in the Milky Way galaxy. Is this true or false? That there are more stars than planets in the Milky Way galaxy. Is this a true statement or a false statement? We've got about 10 seconds left. Get those answers in. And about an even split. The answer is indeed false. There are in fact more planets than stars in the Milky Way galaxy, at least according to our observations and estimate. We think that there are probably almost every star has at least one planet going around it. And we think that there are several stars that have multiple planets going around them. So in fact, we do think that there are more planets than there are stars in our galaxy. Looking once again at our scoreboard, we've got Glowing Sloth, who's maintained their lead Excellent job. Great Rabbit in second and Lively Possum in third. It's a tight race tonight, folks. Going on to our next question. What percentage of stars in our galaxy do we estimate have Earth-sized planets in their habitable zone? So how many do we think have rocky, approximately Earth-sized planets in the region around the star where you could have liquid water, which is what we call our habitable zone here in our own solar system? Is it at least 22%, at least 45%, under 2%, or do we think almost all of them have an Earth-sized planet in their habitable zone? So most of you once again got the correct answer. 22% of stars in our galaxy we estimate have an Earth-sized planet in its habitable zone. So that's pretty exciting. That bodes well if we want to start looking for life in our galaxy outside of our own solar system. All right, we've got Witty Panda in first, Radiant Squid in second, and Decisive Quail has moved to the top three in third place. And we've currently got a tie between Radiant Squid and Decisive Quail. All right, on to our next question, another true or false question. While we have detected thousands of exoplanets, we have never found any evidence for an exomoon. Is that true or false? While we have detected thousands of exoplanets, we have never found any evidence for an exomoon. Is this true or false? That would be a moon that is going around a planet that is going around another star than the sun. And is it true or false that we have never found any evidence? And most of you got the correct answer. Excellent job. That it is false. We have, in fact, found evidence with the Kepler Space Telescope that there is perhaps a exoplanet that has an exomoon. Of course, we assume that in our own solar system, there are lots of exomoons out there, but of course they would be very, very difficult to detect because moons are very small and stars are very bright, and even planets are very bright compared to their moons. All right, let's go on to the scoreboard once again, and it's changed up again. Radiant Squid is now in first, Jolly Piranha in second, and Silver Lion in third. All right. Let's move on to our next question. What type of star was the first confirmed exoplanet found to be orbiting? So what type of star was the first confirmed exoplanet found to be orbiting? Was it a sun-like star, a red giant, a neutron star, or a white dwarf? So what type of star was the first confirmed exoplanet found to be orbiting? Time's up. And, that was a tricky one. In a weird turn of events, the first confirmed exoplanet was actually found to be orbiting a neutron star, which is also known as a pulsar, which is a type of core of a massive dead star, very, very dense object that emits these regular radio pulses. And it was by looking at changes in the radio pulses that we were actually able to see that there was a planet going around it. However, after that, a lot of the planets were found around sun-like stars, mostly around sun-like stars, and much smaller stars as well. All right, let's look at that leaderboard before we go on to the next question. We've got Radiant Squid still in the lead, Inspired Pigeon in the second, and Glad Macaw has moved up to third. It's very tight tonight though, folks, so it could change at any moment. So let's see what the next question brings us. It's another true or false. Most exosolar systems detected so far are remarkably similar to our own solar system. Is this true or false? That most exosolar systems detected so far are remarkably similar to our own solar system. Is this true or is this false? Got about 9 seconds left, so get those answers in. And most of you once again got it correct. It is false. our solar system is pretty different from a lot of the solar systems we've detected out in space. We've detected solar systems where there are gas giants that are really close to the star and maybe some rocky planets farther out. We've detected solar systems where you have planets going around two stars. Lots of and around stars that are very small and red, very unlike our sun. So it turns out that our solar system is not typical at all. All right, moving on. The scoreboard is about the same as it was before. So let's go on to the next question, which is, how small is the current smallest detected exoplanet? Is it smaller than the dwarf planet Ceres? Is it bigger than a dwarf planet but smaller than our moon? Is it bigger than our moon but smaller than Mercury? Or is it about the size of Mars? So how big or how small is the current smallest detected exoplanet? Smaller than Ceres, bigger than Ceres but smaller than the moon, bigger than the moon but smaller than Mercury, or about the size of Mars. And once again, I've clearly made up some very hard questions today, but the answer is that the smallest exoplanet we've confirmed so far is smaller than the dwarf planet Ceres, which is smaller than the moon. So the smallest one so far is about 1/100th the size of the planet Earth. So very, very, very tiny. And very remarkable that with our current technology, we can detect something that's that small. All right, let's look once again at our scoreboard. And once again, has not changed. Let's see, maybe that was too hard a question, but let's see how you do with the next question. So now something a little more pop culture. What is the name of a story written by Laura Givens that takes place on Kepler 36b, a hot planet that is possibly covered in oceans? Is it Turtle Soup? Is it Solaris? Is it Waterworld? Or is it Middle Ground? So Turtle Soup, Solaris, Waterworld, or Middle Ground? So which is the name of a short story written by Laura Givens that takes place on Kepler 36b? It is called Turtle Soup, and it's actually part of a short story series called A Kepler's Dozen, which is 13 stories about actual exoplanets that we've discovered, and people have written sci-fi stories taking place on those planets. So I'd recommend it. I haven't read it myself, but it's on my Amazon wish list. So there we go. All right, let's look at the next, or look at the scoreboard once again. So we've got Radiant Squid in first, Inspired Pigeon in second, Decisive Quail in third, and then Glad Macaw and Proud Ostrich are close behind. All right, our next question is, what is the Fulton Gap? Is it the gap in the distance from the stars? Is it the gap in the distance from the star planets have formed in most systems? Is it the gap in the size of stars around which planets can form? Is it the gap in planetary radii between 1.5 and 2 times that of the Earth? And is it the gap in the rings that form around most planets? So what is the Fulton Gap? So once again, most of you got it. It is in fact the gap in planetary radii between 1.5 and 2 times that of the Earth. And in fact, this is a gap that was discovered by Fulton, this person right here, who, as part of his thesis dissertation, discovered that there was actually a gap between these objects that are 1.5 times the size of the Earth and these objects that are 2 times the size of the Earth. And we think that this might be some sort of transition between rocky planets, super Earths, which are usually around 1.5 times the size of the Earth, and gaseous planets, which are 2 times the size of the Earth or larger. let's look once again at our scoreboard. We've got Radiant Squid still in the lead, Inspired Pigeon in second, and Decisive Quail still in third, so no real changes so far. Let's see how it changes with the next question, which is, how will JWST, or the James Webb Space Telescope, contribute to our knowledge of exoplanets? Will it contribute by discovering new planets around other stars, by using spectroscopy to characterize the atmospheres of planets, by observing the solar systems in their early stages of formation, or all of these? So how will JWST contribute to our knowledge of exoplanets? And most of you got it right. I'm very proud of you. All of these. So we hope that JWST will discover new planets around other stars, use the spectra of those planets to characterize the atmospheres of the planets, so to figure out what sort of elements is in the air surrounding some of those exoplanets, and by observing early solar systems, to maybe learn a little bit more about how our own solar system might have formed and how solar systems in general form. Looking once again at our scoreboard, it hasn't changed too much, except for now Glad Macaw is in third. Our next question is, what element detected in other planets' atmospheres would most likely indicate the presence of life? And instead of element, I should have said molecule. So what molecule detected in other planets' atmospheres would most likely indicate the presence of life? So is it water vapor, methane, helium, or carbon dioxide? So what would most likely indicate the presence of life? Of these molecules. Well, helium, I guess, doesn't have to be a molecule, but. And many of you got the correct answer. It is, in fact, methane, because we believe that there aren't too many processes other than biological ones that would produce methane in the atmospheres of planets that would last a certain amount of time. And there's, more complicated things you have to look at. So it's a bit more complicated than just that, but we do think that seeing methane in an atmosphere would be a good sign for life. All right, let's look at that scoreboard once more. It's changed a little bit. We've now got Witty Panda in third, but Radiant Squid and Inspired Pigeon have maintained their lead. Let's go on to the penultimate question, which is, what color do scientists think plant matter could possibly be on a habitable planet orbiting a red dwarf star? Would these plants be red, brown, black, or green? So what color do scientists think plant matter could possibly be on a habitable planet that is orbiting around a red dwarf star? Red, brown, black, or green? And your time is up. And I think I put the wrong answer in this one, so maybe this one won't count, but it should in fact be black. So the the sun emits most of its light actually in the green part of the spectrum, which is why a lot of plants are green. And we think that plants that are on a planet orbiting a star that has a red dwarf, which has most of its light being emitted in the infrared, would actually be black. So apologies for that. I clicked the wrong answer as the correct one for this one. So that might change the results a little bit. But let's see how the scoreboard is, and we'll see how it changes with the next question. So we have Radiant Squid in first place, Inspired Pigeon in second, Glad Macaw in third, Jolly Piranha in fourth, and Witty Panda in fifth. And this will change a little bit, perhaps, with our last question, which is, what progressive metal band recorded an album called Exoplanet? No astronomy knowledge needed for this one, maybe a little bit of music knowledge. Was it The Contortionist, Dream Theater, Fate's Warning, or Arion? So what progressive metal band has an album called Exoplanet? Is it The Contortionist, Dream Theater, Fate's Warning, or Arion? And the answer is The Contortionist. Most of you got this correct. Good job. And that concludes our questions for the night. Let's see who the winner is. So, in third place, we have Witty Panda. In second place, we have Inspired Pigeon. And in first place, we have Radiant Squid. Yay! So congrats to all of our players. I'm so glad that you all joined me tonight. If you are one of the top three, we will contact you by email and get your info so we can send you prizes. Otherwise, we won't contact you, don't worry. And please do subscribe to our channel. Put those notifications on so you can be notified of our next trivia night, which will probably be in maybe 2 months. And we're very excited to see you next time. Congrats again to all of our winners and to everyone who played. And we hope to see you at the next one. And in the meantime, please do check out some of our content on our channel. Take care, everyone. Good night.